So today we'll look at how to run a age and gender classification model, which uses convolutional neural networks and is pre-trained in the Caffe library, deep learning library. So this is the page, for that particular model. I'll be linking all this in the description. The description usually contains a companion article for pretty much all my videos, and there you should find all the resources. Here, if you look at it, we just gonna download the model, and because we are going to be running this on a Raspberry Pi, we don't have a lot of resources, but the Raspberry Pi can run this model. Although it's a bit slow, it should be able to run this model perfectly. Let me copy this address. Okay. Now here I'm logged into my Raspberry Pi. I'm just gonna make a directory for this. I'm gonna shift to that, and I'm gonna download this model. I'm gonna unzip the model and see what it contains. Let's take a look at this folder. As you can see, it got a bunch of temporary files, which I will remove now so that they cause less confusion. I'm also gonna remove the example image. So we have, let me also remove this Python notebook. We're now left with this Caffe model for age detection, and this is the pre-trained model. These are the weights. This is the file that contains the description of the model, that is the different layers and what they are and how they connect. And the same for, we have two more, the model description and the model itself, the pre-trained model itself for age. So we have two files each for age and two files for gender. Now you might have noticed that there is another file called mean.binaryproto. This warrants a little bit of explanation. So see, what happens is when a deep learning model is trained, there's a lot of training data, and then it's impossible for all the training data to be very consistent. For example, in lighting, right? And then you don't want the deep learning model to pick up features that you don't want to pick up because of differences in lighting, for example, right? So a method called mean subtraction is used, and then it's basically used to fight this difference in lighting, for example, in this particular case. So let's say this model is trained using the ImageNet data set, right? And then there's obviously going to be differences between pictures of two different men of different ages, but you want the system to have a kind of a mean or an average value for each of the channels, for example, RGB in our case, right? So this particular mean.binaryproto file contains those neutralizing factors for each of the pixels. Now, please understand that as far as Opencv is concerned, although you are using a Caffe model, you don't need Caffe installed on the Raspberry Pi itself, because Opencv is enough. It's able to load models from many different deep learning libraries, Caffe being one of them. And Caffe is not going to be there along with Opencv. Opencv is good enough to read the model. Having said that, we need the values from this mean.binaryproto file. And if we are to read this file from any predefined model, pre-trained model, we will need Caffe installed. And trust me, installing Caffe on a system like Ubuntu is not a joke, and it's even more difficult on the Mac. So what I've done is that I have installed Caffe on Ubuntu VM. I'm switching to that VM, and I have a file here. I have a folder here which has the mean.binaryproto, and I have a simple Python script which I will show you now. That's it. It imports Caffe, and then it reads the mean.binaryproto file, it parses it, and it prints the three different values for R, G, and B. So let me run this now. And we have these three values, okay? And these are the three values we need from this, right? We have this and we are good enough. We'll have this and we'll come back to this later on. Now back in a Raspberry Pi, let's get ready to take care of this and write a simple script. Let me remove this zip file and rename this folder to something more manageable. Okay, and I'm gonna open up a file. And we'll start coding away. Now we need to import the Python PyCamera module, because we're gonna read from the Raspberry Pi camera, and we need the image utils, time, and of course Opencv, which is CV2. If you want help installing Opencv on the Raspberry Pi, I'll link to a video in the video description, which you can refer to. Now let's go ahead and initialize the camera. Here you're opening up the camera, setting the resolution, the frame rate, and we're setting up raw capture to a particular array size. Now remember, we got these mean values here. We're gonna store them so that we can use them as we start inferring from the model. We'll sleep just a little bit to allow the camera to warm up. Then as the first step, let's try and capture images and see whether we are able to display them, right? We'll do that before we can we'll go to any other area, right? Here will be our main execution point, entry point. We'll call capture loop. Start capturing frames from the camera, and we'll grab the image from the frame.array, and this is where we use the HAAR Cascade frontal face recognizer, okay, to recognize faces and tell us where in the image the face is. Then we convert the image to grayscale, and we ask the HAAR Cascade face recognizer to detect multiple faces, and we pass the grayscale image into this function. And faces returned will basically be an array of faces that the HAAR Cascade found. All right, so I think it's clear till now. Now we loop faces, where we will be able to get the XY width and height of the detected face itself, and we'll draw a rectangle around the faces found. We're doing this with the Opencv's rectangle function. So we are passing in the image, the original image, not the grayscale, and we are we have the XY and width and height where we want to draw the rectangle. We show the image, we wait for a key press for 1 millisecond, otherwise we continue. We clear the frame, we clear the stream, we check if we press the Q key, and if it was indeed pressed, then we break. So let's go back to this loop again. We set up a camera for continuous capture. We get the NumPy array in image, that is the array which contains the image, and then we set up a HAAR Cascade classifier for full frontal face, right here. This is the location of the HAAR cascade that Opencv installs. We convert the image to grayscale and we pass it on to the HAAR cascade, and we pass it in right here, and then the HAAR cascade function returns multiple faces. It can return multiple faces found. We loop through those faces, get the XY width and height locations, and simply draw a rectangle around the faces. We show the image with the rectangle in a window, and then we get if any key is pressed, and if it is, we check whether if the key is Q, and if it is the Q is pressed on the window, we break, which essentially means we get out of the main for loop, which will end this function and end the script as well. Okay, now let's run this and see what happens. We're done with this Ubuntu virtual machine, so I'm going to shut it down. And I'm gonna log into my Raspberry Pi in another terminal window so that we can easily run the program. Okay, we are in. Let's run this and see. I'm getting into a virtual environment which contains Opencv. If you don't know how to set this up, please refer to my installing Opencv on Raspberry Pi video, which I'll link in the video description. I forgot to pass the X and Y options, which let me remotely open the window. I'm gonna do that now. You should see my face with the rectangle around it. Let's check that. There you go. Hello. I'll press the Q key now to get out. Okay, so we have our basic script running. We have what we have. Let's go back to the script. And what we have done here is that we have set up a loop that captures frames one by one. We have the HAAR cascade. We're drawing a rectangle around it, around any face detected, face or faces, and the script seems to work. Now what we need to do is that the idea is to around each rectangle we also gonna print the gender and the age of the face that is detected. All right. Now the main thing here to understand is that when we pass an image of a face to the Caffe model, the age and gender detector model, we cannot pass the whole image, as the camera captures it, because the model wants a face closely cropped and facing fully frontal. Okay, so what we are doing here is that using the HAAR cascade, we detect the full frontal face, we crop it, and we send the cropped image to the model to predict the age and the gender. Let's start adding support required to get our age and gender model up and running. I'm adding two lists. This is one list which has the range of ages that the model predicts, and of course two different genders. I guess it's not gender neutral yet, but this model has at least male and female right now. Let's load the models. Now right before this loop, the camera loop starts, I want to load these models in. Vim is screwing up all my pastes, but I'm gonna fix that later on. There you go. So now here we have our age and gender models being loaded. We are using the read net from Caffe function, which the DNN, the deep neural network model, the deep neural network module of Opencv has, right? And as you can see, the proto.txt, which basically contains how the model is tagged and how the model is designed, and the actual the weights of the trained model itself, they are both loaded. So these two files for each model are required. Carrying on. Now let me split this into another function. So we have a function now which will return the loaded models, which we will use, let's say, and pass it on to our capture loop function. And we'll pass this to these two models to the capture loop function. And bring these in as well into this function. Okay, now when the script runs, the capture loop function will have access to both these models. Now let's go ahead and see how to infer the age using this model from our frames from the Raspberry Pi camera. Now what I'm going to do is I'm going to create an image of just the face. The beauty about the Python Opencv library is that we can actually just give two different slices of the image, the region of interest we need, and then that which we get from the rectangle, which is available from the HAAR Cascade. We take that and we create the face image. So whenever you see that there's a rectangle drawn around the face, that rectangle or a square, we make it available as a separate image, and we pass that to the model rather than passing the whole image. Now this is the blob from image function, which is there in the deep neural network model of Opencv. This is where we pass the mean values, which we have here on top, right? Which we have here on top, and this will essentially pre-process the image so that it can be passed on to the model for prediction. Let's start predicting the gender. Now let's carefully go through these three lines that predict the gender. So we have gender net, which is the gender's pre-trained model, which got passed to our capture underscore loop function. This function we are currently editing. We say set input and we pass the blob object, which essentially is the image corrected with the mean values, right? And then here's where the magic happens. We say gender.net forward function, which essentially predicts and then returns the predictions. So this is a typical multi classification problem, and what we have here is that a set of predictions are returned, and here we have 1, 2, 3, 4, 5, 6, 7 and 8 different classes possible, right? And we will get returned an array which has basically integers that tell us what is the possibility of each particular class, 8 different classes. So the highest, for example, let's say 15 to 20 turns out to be 0. 0.7. It means that all the others are much lesser than 0. 0.7. It means that we will have to assume that the model thinks the particular input, the person in the input is between 15 and 20 years of age, right? So this is exactly what we are doing here. So gender list is the list we just examined with the different classes. So what we are doing here is that we are taking gender predictions and then we are saying arg max. So we are saying look at the items in this array and return the position of the item which has the maximum value, right? So it selects the right item in the label, right? So let's see some examples of that. It's very easy to see when it's actually printed out, right? So let me print this out. Right. Now I'll go ahead and copy 5 of these lines because this is what happens to age as well. All right, so we have the code to predict age. Now let's form a string so that we can display it near the face of the person on the image. Now this will be our string. We have gender and age. For example, it will say male or female, comma, the age range, right? And then we use the cv put text function, which essentially displays text, OpenCV's way of displaying text. We are missing the font here, which I will now copy. Let me put this outside the for loop. All right, this will be a font. Okay, if save this now, we could try running this. Okay, we are in the wrong project, I guess. Age gender model, deploy age. Where's the problem here? It's unable to load this. Okay, we've specified the name as models here. Let me correct that and go back, clear the screen. Okay, there we have it. It's pretty confused about my age. It also thinks I'm female. Let me reduce the font size a bit. Going back, this is the font scale. We can reduce that a bit and run it again. Okay, there you have it. Let me quit this. Now, I wanted to focus on these two outputs. This is the prediction of male and female. So it thinks this is the possibility of the person being male and the possibility of the person being female. And this is the different possibilities of the age ranges, right? So because we're using the function here which says argmax, it's going to take whatever is the maximum, and we are using that index to select one of these items from the list, right? So this is how you can use Caffe models in Opencv. It's very, very easy to understand, and it's pretty powerful, because although you cannot train very successfully on the Raspberry Pi, you can use very powerful deep learning toolkits and create models, train models, and take those pre-trained models, load them on the Opencv, and run them successfully, right? And it doesn't stop there. There are other deep learning models as well. As an exercise, you can go and find out what other deep learning toolkits are supported by Opencv, right? That's one thing you can do. And of course, it's a little bit slow because it's running on the CPU, number one, and number two, single core performance, CPU core performance on the Raspberry Pi. It's nothing to write home about, right? But nevertheless, it's a very interesting idea, and hopefully you'll get a lot more excited and check out all the other pre-trained models available. There are lots of pre-trained models available, and you can do many interesting things with Opencv and pre-trained models from other deep learning frameworks. I hope you enjoyed this, and see you until next time. Bye bye.